All right, we did this in applied math. We're looking at polynomials today. We talked about end behavior, remember that? And what happens if in polynomial functions, just the transformations of polynomial functions. So basically the difference between that and what we're going to do today is, again, we go back to the A, B, C, and D, and we work with the movement of polynomial functions. But the first thing we want to do is let's look at the polynomial function where you have, in order for it to be a polynomial function, okay, Brennan, you gotta go. You have to have a variable x to an exponent n. Okay? So in order for it to be a polynomial, you have to have an n value in which the n is a whole number. Now the degree of it depends on the highest value of exponent in the actual polynomial. Okay? X is a variable, the coefficients a are real numbers, the degree of the polynomial function is n, the exponent of the greatest power of x, the leading coefficient a is the coefficient of the greatest power of x, the constant is the a to 0. Okay, basically what we need to know is this, like let's take the very basic one. Okay, so normally we put them in numerical order in ascending order of these guys. Descending, I don't remember which one it is. Anyways, so the degree of this guy is what? 2. Okay? The leading coefficient in this guy is 2 as well. Alright? So this basically determines whether it opens up or down. But what it tells us is what the end behavior of this is. That's what we have to be focused on. Now in applied, you could write out what all the end behaviors were for each of the polynomials. In a pre-calculus we can. So we have to remember them. So what we do is we try and remember them based on whether or not that leading coefficient is odd or even. Okay? So, types of polynomial functions, a degree of 0. That's when x is to the power 0, which means that it's a constant, is your only variable, and the line is a horizontal line. Degree of 1 is a linear. Degree of 2 is a quadratic. Degree of 3 is a cubic. 4 is a quartic, and 5 is a quintic. And what did we learn about the number of turns from applied?
Oh, isn't it like your degree subtracted one?
Yes. It's 1 less than your number of degree. Okay? The end behavior, all right, of an odd function is always the same. So an odd function is a cubic function. So the easiest way to remember this stuff is to quickly draw it out. So the end behavior for a cubic function is what? A positive leading coefficient. What's the end behavior of this? 3 to 1. Okay? A quintic function would be the same thing. 3 to 1. Exponent to the 7, 9, whatever. As long as it's an odd exponent, it's always going to be 3 to the 1 if the leading coefficient is positive. If the leading coefficient is a negative for this guy, your end behavior changes to what? 4 to 2. Same for all odd exponents. Okay? Let's look at the even exponents. So what's the first even one we do? X squared. What's the end behavior for x squared?
2 to 1.
2 to 1. What about negative x squared?
3 to 4.
3 to 4. Same for x to the 4th, x to the 6th, x to the 8th. Okay? So again, all of this stuff we've hashed out already. We just need to go through and then we'll talk about transformations as they go. This is the last of it. We do the polynomial functions for this. We've done the square roots. We've done the basic transformations for all graphs. This is the last of it until we get into, we do some trigonometry work, and then at the end of the trig we go back to the shifts again. Okay, follow through on page 68. Write your answers out. Which of these functions are polynomials? Justify your answer. G of x equals 4 to the x. Polynomial or not?
No, it doesn't
No.
have an x variable. Because it isn't a variable.
It's got to have an exponent of a numerical value, a whole number, and the variable x has to be the base. It's got to be in the form of this. The exponent, that's an exponential function, that first one. So there's the answer to the second part. It's an exponential function. The base of 4 to the x is, what is it? 4. And the exponent is a x. Good. The function h of x, 6 minus 5x cubed, is, yes. What's the leading coefficient? Negative 5. Degree is 3, and the constant is 6. 6 is the constant is the term that does not have a variable with it. Okay. Y equals x to the negative 2 plus 1. Is or isn't?
Can you have a negative?
You cannot have a negative. N has to be, look at that very first statement there. N is a whole number. Okay? So it has to be a whole number. So the answer is no. So that one, how do I make that a positive exponent?
Oh, put it over one.
Put it where?
Either over one or under one.
Under. So I get that. Okay? X to the negative 2 is the same as 1 over x squared. This function is a reciprocal function. It's what we call a reciprocal function. 1 over x squared. What about D? No. It's not. It can be written as x to the power of what? 1/3. Thank you. Well done. 1/3. Good job. Okay? Which has a 1/3 as your exponent. So therefore, this is a radical function. So you got that written down? Your book? Yeah? Okay. Second part, match the equation with the graph below. 2x cubed minus 4x squared plus x plus 2. Which one is it? What is it? C? No. What's the degree of it? Degree is 3, right? So it's what? D. Easiest way to figure this out from the graph? Number of turns, that's right. Georg. So what about B? Which graph is it?
B.
Is it big B? 3 turns? Yes, that's right. How about C? A, 4 turns. And D? C, 3 turns. Sometimes those turns aren't easy to see on those ones. Okay, so I've gone through all that. I don't need to do that. And then the last thing you have to do is working example 3. Application of a polynomial function. Antibacterial spray is tested on a bacterial culture. The population P of bacteria in T minutes after the spray is applied is modeled by the function P of T equals negative 2t cubed minus 2t squared plus 3t plus 800. What is the population of the bacteria after 3 minutes? So what do I got to do here? Put 3 in for t. Okay, so I'm going to write that out. Help me out with this. P of 3. So what is it? What's the equation? Minus
Minus
2,
2 times
3 cubed,
subtract 2 times 3 squared, plus 3 times,
plus what?
plus 3 times 3,
Thank you.
plus
800?
Yeah.
Okay. 27, right? Negative 54. 9 minus 18 plus 9, add 800. Okay. What is that? Minus 72. Add 9. Minus 63. 63 off of 800 is that. Does that look right? Okay. So there's that many after 3 minutes. How many bacteria in the culture before the spray was applied? 800. Yes. How do we know that, Lexi?
Because it's our constant.
Yeah, and why else?
Put zeros in, it's only kind
Exactly. Okay, you got both the answers I was looking for. What's the population of bacteria after 8 minutes? Negative 328? Is that even possible? No. Can't have a negative amount of those. Okay? All right. So, your test Tuesday. Okay? You have a review. You have a pre-test. You've done all that. Work on 3.1. Fair enough? Any questions from yesterday?
Oh, yeah.
Yes, Lex.
On page 62, question 7.
Oh, I did this with you yesterday. Okay. You have a 0 of x equals 8, which means your y value is 0. Right?
Yeah.
So let's put that in for x and y. So y is 0. X is 8. I have that. Okay, so far?
X is 8 because y. I thought that was like a root.
It is.
That's where we put our roots usually?
No, you're putting it in for x.
Oh, okay.
The coordinate
Oh,
is
I see.
8 and 0.
Okay.
Right? The coordinate in the next one is what? Negative 2 and 2? Oh, 2 and negative 2. So it's negative 2 equals 2b plus k, like that. So far you're okay?
Yeah.
Alright, so what I'm going to do then, this becomes k equals negative root 8b. Right?
Yeah.
Just rewriting it. So if that's the case, I'm going to put that in for k over here. So I get negative 2 equals 2b subtract 8b.
Okay. Negative 2 equals the square root of negative 6.
Absolutely not.
Sorry.
Can't add apples and oranges.
Oh, yeah.
Remember, radicals have to be treated like x's and y's or a's and b's. They have to be exactly the same. So what do I have to do? What have we been working on? I got to isolate one of the square roots. So I get square root 8b subtract 2 is equal to root 2b. I isolated one of the square roots. Okay? So now you got to square everything. So now I'm left with 8b minus 4 times 8b plus 4 equals 2b.
Wouldn't it be possible on the first one?
Again, that's not squared and that's squared. You don't do that. You have to FOIL that.
So I understand how you got 8b subtract 4. Where's the square root of 8b plus 4 coming from? Oh, never mind, 4. Oh, sorry, I got it. Okay.
Right? So -2 times that, -2 times that, and you have to get it gives you -4 of those. So far so good? Okay? Again, now you gotta isolate your square root. So I've got -4 root 8b is equal to 2b subtract 8b, -6b, subtract 4. I'm going to times everything by -1 because I do not like that. And then I square both sides again.
Would it be plus 4?
No, that's good. Yep, thanks. Thank you. Is that where we got to? On?
No, 80.
Oh, 80. Right.
And then I just have to do my root equation thing.
I divide everything by 4. That gives me 9b squared minus 20b plus 4. Use your factoring. 3 equals 2 plus...
Do you have to keep the 4 on the outside when you do that? When you simplify?
No.
Does
No,
that-
because I'm solving, I can divide, and it gets rid of it. If I was factoring, yes, but I'm actually solving, so I factor it out by dividing everything, including the 0 by 4. That's why. Because it's an equals to,
Oh, okay.
I can divide by that. Okay? You alright?
Yeah. I think so.
Okay, and then you gotta solve by factoring. It's not a question you're gonna see again. But. Any other questions today? Yeah, Gary.
4b on page 60. When you're just checking to see whether the roots are extraneous or not, and you have like say 30, square root of 36 is equal to -6, that doesn't work, right?
Yeah, it does.
Oh, okay. And it does not. Okay.
But let's make sure.
Yeah, do you mind still going through?
Yeah, it does, because in theory you have plus minuses, but
Yeah.
you take square roots.
Yeah.
So it can equal a -6 there.
Okay. Thanks.
Does it give that to you in the, as part of the solution though? Do you want to look in the back there, please?
Okay. Yeah, it only gave me the other one where it didn't give me the one where it was.
Okay, so if you've got it as the square root is equal to a negative number, it can't be done.
Yeah. That's what I figured too.
Okay.
but
Yeah, I just wanted to make sure of that. All right,
Yeah, that's.
okay, anybody else? Okay. You got lots to work on for Tuesday.
So all this has to be done for Tuesday then? Or I guess we have our test.
So 3.1 needs to be completed for Wednesday.